Hi students, welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic today we are going to discuss is from chapter 10 Wave Optics. Already we have given 7 questions in the questionnaire session. Today is a problem solving session for these wave optics. Let's see question number 1. Two coherent sources of light interfere and produce fringe pattern on a screen. For a central maximum, the phase difference between the two waves will be dash. I think most of you may got answer. I think option A, 0 is the correct answer. What is the formula used? Formula used is phi equal to 2 pi by lambda of del. Here phi is the phase difference and delta is the path difference. Delta is the path difference. And for central maximum, path difference is 0. Okay, for central maximum at that point, path difference, no path difference. If there is no path difference, then delta equal to 0. If delta equal to 0, then phi equal to 0 into 2 pi by lambda, that is 0. So option A, 0 is the correct answer. Let's move to question number 2. In Young's double slit experiment, if the separation between coherent sources is halved and the distance of the screen from the coherent sources is doubled, then the fringe width becomes dash. Actual formula for this is beta. Beta is the fringe width. Beta equal to lambda capital D by small d. Beta is the fringe width. Lambda is the wavelength of the light source used, and d is the distance between the source and the screen, capital D, and small d is the distance between the two sources, two coherent sources, that is small d. And here separation between coherent sources, that is d2 is halved. d2 equal to d1 by 2. And distance of the screen from the coherent sources, that is capital D, is doubled. d2 equal to 2 times of d1. Then beta 2 by beta 1. Beta 2 by beta 1 equal to lambda 1 equal to lambda 2 equal to lambda same. So lambda getting cancelled, and then we'll write the remaining thing, d2 by small d2 into beta 1, that is d1 into d1. Substitute d2 equal to 2d1 and small d2 equal to d1 by 2 equal to d2 is 2d1 divided by this d2 is d1 by 2 into d1 by d1. This d1, d1, this d1, this d1 getting cancelled. 1 by 2, 1 by 1 by 2 comes up 4. So beta 2 by beta 1 equal to 4, or beta 2 equal to 4 times of beta 1. Beta 2 equal to 4 times of beta 1. So 4 times. Option B, 4 times is the correct answer. Let's move to question number 3. Assume that light of wavelength 600 nanometer is coming from a star, some distant star. The limit of resolution of telescope whose objective has a diameter of 2 meter is dash. Correct option is D, 3.66 into 10 power minus 7 radian. What is the formula? D theta is the limit of resolution equal to 1.22 times of lambda by D. And lambda is given 600 nanometer. Lambda equal to 600 nanometer, convert into meter. 1 nanometer equal to how much? 10 power minus 9. 10 power minus 9 meter. And diameter, small d is the diameter, d equal to 2 meter. Substitute this here. Then d theta equal to, that is the limit of resolution, equal to 1.22 into 600 into 10 power minus 9 divided by d is 2. Then 3 times 2, 300. And d theta equal to 300 I am taking as 3 into 100. Then 3 multiplied by 1.22, then we will get 3.66 into 100 is 10 power 2, 10 power 2 into 10 power minus 9. 10 power minus 9, 10 power 2 is 10 power minus 7. Therefore, d theta equal to 3.66 into 10 power minus 7 unit radian. That is option D. Option D is the correct answer. I think maximum number of students got answer. Okay. Let's move to question number 4. The ratio of resolving powers of an optical microscope of two wavelengths, lambda 1 4000 Armstrong and lambda 2 6000 Armstrong is dash. What is the relation between resolving power and wavelength? Resolving power is the inversely proportional to wavelength. RP is inversely proportional to lambda. And two wavelength is given. Lambda 1 equal to 4000 Armstrong. That is 4000, 1 Armstrong equal to how much? 10 power minus 10 meter. And lambda 2 6000 Armstrong. 6000 Armstrong into 10 power minus 10 meter. Then two wavelength, two cases, resolving power RP1 is inversely proportional to lambda 1 and RP2 is inversely proportional to lambda 2. RP1 is inversely proportional to lambda 1 and RP2 is inversely proportional to lambda 2. Then you want to find the ratio of resolving power of an optical microscope, RP1 by RP2. RP1 by RP2 is equal to lambda 2 by lambda 1. Lambda 2 by lambda 1, lambda 2 6000 Armstrong. 6000 into 10 power minus 10 divided by 4000 into 10 power minus 10. 4000 into 10 power minus 10. Then 10 power minus 10, 10 power minus 10 getting cancelled. These 3 0, these 3 0 getting cancelled. And if you use two table, 2 2 4, 2 3 6. So 3 by 2 is equal to 3 by 2. That is only 3 is to 2. That is option C. Option C, 3 is to 2 is the correct answer. Let's move to problem number 5. In a diffraction pattern, due to a single slit of width A, the first minimum is observed at an angle of 30 degree when light of wavelength 5000 Armstrong is incident on the slit. The first secondary maximum is observed at an angle of dash. That is, for first minimum, formula is A sin theta equal to n lambda. And here A, theta is 30 is given. So sin 30 degree equal to first minimum, n equal to 1. So 1 into lambda. Then what we will get? That gives A sin 30 is 1 by 2. A into 1 by 2 equal to lambda, or A equal to 2 lambda. Okay, A equal to 2 lambda. Then what is the question? First secondary maximum is obtained at an angle. First secondary maximum A sin theta 1 equal to 3 lambda by 2. Okay, and theta 1 only we are going to find. Then sin theta 1 equal to 3 lambda by 2. Then sin theta 1 equal to means A will goes there equal to 3 lambda by 2A. And A equal to 2 lambda, just now only we found. Then 3 lambda by 2 into 2 lambda. So this lambda getting cancelled. Then sin theta 1 equal to 3 by 4. Sin theta 1 equal to 3 by 4. Theta 1 equal to sin inverse of 3 by 4. Sin inverse of 3 by 4. Sin inverse of 3 by 4, that is option C. Option C is the correct answer. Let's move to question number 6. A linear aperture whose width is 0.02 centimeter is placed immediately in front of a lens of focal length 60 centimeter. The aperture is illuminated normally by a parallel beam of wavelength 5 into 10 power minus 5 centimeter. The distance of the first order dark band of the diffraction pattern from the center of the screen is dash. Yes, option D, 0.15 centimeter is the correct answer. Formula used here is y equal to lambda d by a. Lambda capital D by a. Lambda is a given value. How much? Is given in 5 into 10 power 5 minus 5 centimeter, and focal length, that is equal to D, capital D, 60 centimeter, and linear aperture width 0.02 centimeter. All the value given in centimeter, you should convert into meter. But even the option also given in centimeter. So no need to convert into meter. Keep in centimeter itself. Then lambda d by d substitute. Lambda is equal to 5 into 10 power minus 5. 5 into 10 power minus 5. As I said, keep that in centimeter itself. D, that is equal to focal length 60 centimeter into 60 divided by width is 0.02 centimeter, keep as 0.02. Then 6 5 30. Then 300 into 10 power minus 5 divided by 0.02. To bring 0.02 to normal 2, multiply and divided by 100. Y equal to this 300, this 10 power 2 I am taking as 3 divided by 2. This 10 power 2, this 10 power 2, 10 power 4. 10 power 4 into 10 power minus 5. 10 power 4 into 10 power minus 5. Then 3 by 2 is 1.5. 1.5 into 10 power 4 into 10 power minus 5 is 10 power minus 1. 1.5 into 10 power minus 1 is nothing but 1.5 divided by 10. That is equal to 0.15. 0.15. And already is in centimeter. We haven't converted into meter. So 0.15 centimeter. That is option D is the correct answer. Let's move to last question. The angular resolution of a 10 centimeter diameter telescope at a wavelength of 5000 Armstrong is of the order of dash. We know already the formula, angular resolution d theta equal to 1.22 times of lambda divided by d. And lambda is given in Armstrong, convert into meter. So equal to 1.22 into lambda 5000 Armstrong, converting into meter, 5000 into 10 power minus 10 divided by d. D is in 10 centimeter. Centimeter convert to meter. Oh, 10 into 10 power minus 2. Then 10 into 10 power minus 2 gives 10 power minus 1, and 1.2 into 5. 1.2 into 5 into 10 power 3. I am writing like this just to simplify. 1.22 into 5 into 10 power 3 into 10 power minus 10 into 10 into 10 power minus 2 is 10 power minus 1 is equal to 1.22 into 5, that is 5 to 10, and 5 to 10 11, 5 1 5 6, 6.10 into 10 power 3 into 10 power minus 11. Right? Or 10 power minus 1 comes up, 10 power plus 1, yes. So 10 power 4 into 10 power minus 10, you will get 10 power minus 6. So 6.10 into 10 power minus 6 is of the order of means approximately. Approximately it is 10 power minus 6 unit radian. This angle is a radian. So that is option D. Option D is the correct answer. Thank you, students. So in next session, we will give the 7 questions as usual from the next chapter, and next session, we are going to solve the solution of that respective concerned subject 7 questions. Okay.